Next up is Tong.
The topic of my presentation is cloning to detect genetic disease or birth defects of fetuses. The way that use clone technology to detect genetic disease or birth defects of fetuses is to clone genes of a zygote, not use these genes to compare with disease-causing genes that are in the database to know whether the zygote is normal. The procedure can generally divide to 3 steps. The first step is collecting data and building database. In step 1, we need to clone disease-causing genes so that we can obtain different genes of abnormality. We also need to research the family history to decide whether or not the abnormality is genetic disease. If it is, we need to find the family history of genetic disease. We also need to build databases to keep these genes and information for future reference. Now I'm going to introduce how to clone disease-causing genes. I'm going to show you a short animation. It will give you a clear process of cloning.
First step in cloning a gene is to isolate the DNA from the organism that contains the desired gene. The isolated DNA is purified and then fragmented with a restriction enzyme. Restriction enzymes used in cloning produce staggered cuts in specific sequences in the DNA, generating fragments with cohesive ends. Each fragment has a single-stranded sequence of nucleotides on its ends that is capable of hybridizing with DNA that has been fragmented with the same restriction enzyme. The DNA fragments are then incorporated into plasmids. The type of plasmid used for cloning has a single restriction site, and when cleaved by the restriction enzyme, generates the same cohesive ends that are in the fragments of the DNA to be cloned. The cohesive ends of the plasmid and DNA fragments now line up, and the enzyme, DNA ligase, is used to form phosphodiester bonds. The next step is to incorporate the plasmids into bacterial host cells by transformation. Each cell contains a different segment of DNA from the original organism. Taken together, these cells represent a DNA library. The cells can now be plated out on an agar medium. The colony of cells containing the desired cloned gene can then be identified and isolated.
disease-causing genes and study mutations. The picture on the right is one of mutations is found. It is number 3 and number 13 chromosome mutations of a man.
You have about 1 more minute.
The second step is clone genes of the zygote. The method is the same as clone disease-causing genes. The step 3 is the step 3 is compare the genes clone from zygote with disease-causing genes packaged in the database. If mutations are found in the zygote, we can prevent the growth of that zygote, so that we can stop the fetuses that has genetic disease or birth defects from growing in time. Conclusion, although genetic disease and birth defects are not open, they cannot be predicted. Once they happen, the effects are very serious, so detecting them before happening is very important for humans. Detecting genetic disease and birth defects are a complex process, so far cloning technology plays an important role in this field.